today we're going to talk about types of science inquiry. What is inquiry-based learning? According to the Smithsonian website, inquiry-based science adopts an investigative approach to teaching and learning, where students are provided with opportunities to investigate, search, make observations, ask questions, test out ideas, and think creatively. If you look at the image that I have that says inquiry, it talks about the process of inquiry. So it starts with identifying, then exploring, modeling, evaluating, and then explaining. The next image I found, I think, explains the levels of inquiry very well. Now, in my research, I found that some researchers evaluated to 3 levels and others to 4. And I also found that they name them or call them different things. So if you look at this image, it says that it starts out with structured inquiry. So the students are very limited in what they can do, and eventually it goes to the students being able to explore, and the teacher is more or less observing. So level 1, known as controlled inquiry or confirmation inquiry, students confirm a principle with an activity. Then students follow the lead of the teacher as the entire class engages in one inquiry together. Level 2 is known as structured or controlled inquiry. This level is similar to level 1, but now involves developing a foundation for inquiry and critical skills. So the teacher chooses topics and identifies the resource students will use to answer questions. Level 3, known as guided inquiry, activates thought-provoking conversation, and nothing is under the student's control except the actual manipulatives. So the teacher chooses topics or questions, and the students design a product or solution. Level 4 is known as open inquiry, open exploration, or free inquiry. Students have control over a wide range of questions, and they also have control over the means of practice of investigation. So students choose their topics without reference to any prescribed outcome. And now Alex is going to go into what this looks like.
All right, I found some example activities that illustrate each level of inquiry. So the first one I found is paper helicopters. So if you want your students to confirm that less air resistance an item has, the faster it will fall, they can test this theory by making these paper helicopters with varying wing lengths and then carry out the activity and record their data and assess their findings. The next activity we have is called dancing raisins, and this is an example of a level 2 structured inquiry. And you may have seen this activity before, where you have the students fill a glass with either soda or baking soda and vinegar mixture, and then they can observe that the raisins go up and down, and then the students discuss their observations and identify why the raisins are behaving this way in the solution. And then the third activity that illustrates the level 3 guided inquiry is called the soda can float, and this you give students cans of regular soda and cans of diet soda and ask them to predict what will happen when they put them in water, and then the students will be surprised that the regulars can sink while the diets bob at the top, and then they're asked why they think the phenomenon is happening. Then the next activity that brings it all the way to a level 4 and more open and free inquiry is just a sinking and floating activity, where you set out a bunch of different items and students can choose from all the different items and then make their predictions. And then after the activity's over, they can ask 5 I wonder questions that will inspire further activities for them to explore, and maybe bring in some of their own items and have even more free inquiry. So the benefits of having this kind of inquiry in your classroom is that it encourages curiosity and then brings a deeper understanding for students in this content area, and then it allows the students to really take ownership of their learning and bring this knowledge to real life context, and it allows your students to interact with the manipulatives and different items and experiments, and creates a really fun learning environment. Now Sarah and I wanted to make sure we brought some connections from that we see with inquiry science and other ideas and theories that we've learned about from this class and other classes. I noticed that the two, inquiry science and understanding by design, really can work together to have similar mutual goals. We learned from that video with Jay McTagg that the goal of understanding by design is really understanding the topic and having a deeper understanding of your content and getting beyond just the content, and then also to have those ideas transfer to other content areas. So I think we can see that inquiry science and understanding by design can really work well together. And Sarah has some connections to share as well.
Some connections I made are Bloom's taxonomy, problem-based learning, and project-based learning. So in Bloom's taxonomy is broken down into 7 levels: remembering, understanding, applying, analyzing, evaluating, and creating. Creating is the highest level, and the lowest level is remembering or recalling facts. Inquiry-based learning is also very similar to problem-based learning and project-based learning. So they are all very student-centered, encourages active learning and critical thinking, and show effective models for learning. Now, problem-based learning, students need to solve an authentic real-world problem. Project-based learning is students need to create a project or some sort of material. And inquiry-based learning begins with an essential question or questions. Thank you very much.